Get it? What's that? Yes and no. You can record my voice, but you're not allowed to video me, although we are recording the lecture, which we will post after it's done. But should you take that as, oh, okay, I don't have to write anything? Definitely not. You still need to write this stuff down, because what's going to happen is you're going to come to a point where if you're missing a piece of this information, you can't move any further forward, and all you get is frustrated. And I'm just trying to save you from that, because I can't tell you how many emails I get from UV mapping where people are like, I have no idea what's going on. It's not working. What's wrong with mine? Maya's the devil. You know, I get all those. And typically, it's they're missing one crucial step. And it's such a small thing, but it stops you completely from moving forward. Does that make sense? So I just want to make sure you know going into it. UV mapping is going to challenge you, so be ready for that. All right. Now, in terms of UV mapping, why we do it, and that kind of thing, I think it's a good idea to kind of take a look at what UV mapping can do for you, and then you very much appreciate why we bother going through a process that is somewhat less than fun. And that is because of the tremendous benefit of being able to apply textures or color information to your geometry. Now, if you take a look at my little guy here, this is my Lego me, and we know if we want to see him in wireframe, we press what? 4 for wireframe, right? Shaded is 5. And if we want to see him with his texture on, we can press 6 on our keyboard, and 6 is textured mode. And what that allows us to do is see our objects, whatever they happen to be, with the texture on it. Now, granted, this isn't what the final render will look like, the final image that we generate, but it gives us a very good idea of what the texture will look like and where the texture will appear. And those are the things we're always worried about. Ballpark, how does it look, and is it in the right place? Because we literally have to figure that out. Now, in terms of the texturing, what we want to do is basically take a complex 3D object and lay it out flat, because it is easier to paint something that's flat. For example, if you know that cardboard tube inside of a paper towel roll, you know what I'm talking about? It's great to like torture the dog with it because it makes your voice sound funny. But in terms of that cardboard tube, the cool thing about it is it's kind of difficult to paint on a curved surface. So if I asked you to paint something, that's going to be hard. But if you take a pair of scissors and you cut that tube and lay it out flat, now all of a sudden that's something that's way easier to paint on because we're used to flat stuff. So that's not so bad. Does that make sense? And then I can roll it back into a tube, put a little tape on it, the side that I cut, and then turn it so you don't ever see the cut. All of a sudden, I look like an artistic genius. Does that make sense? So it's all about where do I place that cut, and isn't it easier to paint it when it's flat? So what we're going to do is take a complex 3D surface, and we're going to make it look flat so that we can paint on it. So ultimately, we are doing what we call creating UV shells. And these shells represent the geometry laid out flat. Now, if you want to see the UV shells or the layout of a piece of geometry, you're going to go to the UV editor. And in 2017, it's got its own little category now. If you click on UV, right at the top, you'll see the UV editor. And when you open that up, you'll see that it's got its own little menu of tools, just like any other window in Maya. There's some buttons here that are shortcuts to those menu sets. But what you notice right away is it is indeed an orthographic view, much like your other orthographics. And you see that there's this grid in here and then a big, huge, wide open space. And this area out here is your workspace, and it's basically like a big desk. So you can do a whole lot of work out here. And just like having a big, clear desk makes it easier to do art on than a small cluttered one, same idea holds true. This is where I'm going to work on stuff. Ultimately, though, when it comes to putting texture on geometry, I want to make sure that my UV shells fit into this quadrant of the grid. This quadrant is called the 0 to 1 space. 0 to 1. And the reason it's called 0 to 1 is between 0 and 1 there are infinite numbers, because you can always have a smaller number. Half, quarter, eighth, 16, 32nd. There's always a smaller number. So ultimately, I'm going to place my UV shells in this area, because this is where Maya goes by default for diffuse color information. And that's how Maya will apply textures to specific locations. Does that make sense? So for example, you might be looking at this and going, well, I don't see any UV shells. What's going on here? That's because I haven't selected anything yet. When you select geometry, you then see its UV layout. Does that make sense? That's what's going on there. So if you take a look at this, if you take a look at, let me just uncheck that. When you take a look at this, you can see this is my character laid out flat. You know, there's my shirt. That's the opening where my head goes, right? That's where my arms go. There's my legs. There's my little face, right? And this is my head laid out flat. What we want to make sure of is that we get a good layout, because if we make a poor layout, you can see that poor layout yields distortion in my texture. Does that make sense? So what we're trying to do is accurately represent this 3D entity in 2D. Does that make sense? Overall concept? Okay. All right. Let's get into the specifics, knowing what we know about that. All right, here we go. So again, UV mapping is the process of organizing a surface and laying it out flat so we can apply a texture to it. To better understand UV mapping, I'm going to draw some parallels between things that we do understand, and that is maps from our world. So let's take a look at this map of Attu, Alaska. So let's say you say, hey, you know what, Steve, we would love to visit you in the summertime. Where do you hang out? I say, well, I've got this lovely home in Earl Cove in Attu, Alaska. And if you say, okay, so how do I find Earl Cove? And I tell you, well, if you kind of imagine the island looks like an elephant, and if you go over sort of the first bump in the back of his neck, that's where Earl Cove is. So if A, that looks like an elephant to you, and B, you can fly, you can figure out where Earl Cove is. Do you guys see the elephant when you look at that? That is a bit of a Rorschach test. All right. Now, it vaguely looks like an elephant. Right. But if I tell you C2, everyone in this room and everyone on the planet Earth can find Earl Cove. Does that make sense? The grid takes an analog concept of surface area and digitizes it and organizes it so the broadest number of people can understand. Mutual understanding. Does that make sense? Understanding is a big piece of UV mapping. But the people who need to understand each other are you and Maya. Does that make sense? We work together, we need to understand. So that's a big piece of UV mapping, understanding. Now, we can map complex curved surfaces. I mean, it's true, the island is relatively flat, all things considered. How do we map the Earth and figure things out? Well, we do map 3D surfaces like the Earth, but we use different means of doing that. We use longitude and latitude. Longitude and latitude help us organize the entire surface of the Earth. As long as I have the coordinates, just like C2, just more complex. As long as I've got the coordinates, I know exactly where I am on the surface of the Earth. But the issue that I run into is I can't see the other side. So in terms of my understanding of this complex curved surface, I have to have a globe with me to be able to see the other side of what I'm looking at, which is not very convenient for putting into my pocket, and also not very convenient for writing or drawing on. Does that make sense? So I have to do something else. I need to lay it out in a different format. I'm going to lay it out flat. You've probably seen a map like this before, right? This is the Earth laid out flat so that I can see all of the surface areas at one time. It's still got a grid. I still understand where things are, but now I can see everything at one time. So what I have to do in order to make that, though, is I have to put sort of cuts in my sphere to lay it out flat, kind of like peeling an orange. You know, you can't peel it off and it's still in a round shape. When you look at the skin, it's going to come off in pieces. So I have to put little cuts in my map or my shell in order to lay it out flat. But you can see how they would kind of go back together and make a rounded object. Does that make sense? You can almost see that. Big ticket item, where are the cuts? Where did I put them? This is the interactive part. Where did I put the cuts for my map of the Earth? In the ocean. Is that by accident, do you think? Why would I put it somewhere else? What do you think?
It would create issues with where the continents line up.
It could cause issues with where my land masses are organized and how they line up.
It'll make it more difficult to cut through the U.S. and have to make sure you're in the exact same lines on one side of the exact opposite.
Exactly. I'm having trouble with understanding, and I'm starting to have some concern over accuracy. Does that make sense? Because those are the two things you have to have with a map: mutual understanding and accuracy. An inaccurate map is not helpful. Does that make sense? If I'm going from the tip of Africa to the tip of South America and that distance is incorrect, I might be doing a lot of paddling when I run out of gas. Does that make sense? So maps do two things. They have to have mutual understanding, clarity, and they have to be accurate, or they're not good maps. I put the cuts in the ocean because it saves me from adding confusion in terms of what's going on there. And in terms of detail, are there really important details in the water? No, the water's just blue in general, so not as big of an issue. Does that make sense? Put those cuts there. If I was doing a topographic map of the bottom of the ocean, I would probably put the cuts through the continents, because at that point I'm really concerned with the ocean, not the continent. Does that make sense? So it's all about what do I need to show. And in this instance, the water is just blue. That's a great place to have a cut or a seam in my map, because if I did fold the Earth back together again, that blue part would probably go back together more easily and cause less attention to be drawn to it. Does that make sense? Yeah. Well, we talk about texture seams. Where do we put the seams on our UV shells? And that's exactly that thought process. Where do I put the seam? Because if I'm taking a complex 3D object and I'm laying it out flat, I have total control over where the seams are. We're going to talk more about that because it's critically important when it comes to UV mapping. But that's a great question. Great question. Where do we put the seams? Now, just a quick thought process. When I'm doing the texture for my character, you'll notice that my chest has a lot of detail on it, right? My arm, not so much. If I had to put a seam on my character somewhere, do you think I would put the seam right across my chest? That could be a problem, right? What about the arm? Is there a lot of detail there? Now, kind of like the ocean, a little bit more flexibility with my seams. Does that make sense? Just important things to think about when it comes to UV mapping. So again, we want to make sure we've got a good UV layout for our geometry, because that UV shell is our guide. Now, we talked about the two things that are most important when it comes to UV mapping. That is mutual understanding and accuracy. So mutual understanding, I get that. I have to lay out my UVs in such a way that I know where I am on the surface of the object, and Maya knows where Maya is on the surface of the object, because we are a team. Accuracy, I've got to look out for that. In order to determine the accuracy of a UV layout, we apply a checker material to the object. And the checker material tells us how good or bad our layout is. Because sometimes you look at a layout and you're like, I don't know if it's accurate. I'm not really sure. How big is the Earth? What is the diameter? Is it the same on the top as well as the bottom? Those things are all different. The Earth is actually kind of pear-shaped, really. We're not a sphere. But when it comes to models, how do I determine good layout? We apply a checker pattern to the material, and that's our guide. Because the checker pattern is made of happy, perfect little squares. So if I have good UV layout, I see happy, perfect little squares. If I have poor UV layout, I see distortion in my squares. Does that make sense? That's my guide. First, I lay out my UVs. Then I try to make them look as good / accurate as possible. Then I can go into generating a texture. Now, in terms of my layout, if you look at my little Lego guy, you'll notice two things. Number one, the squares are the same size for every piece. You notice that every separate part of my guy, same size squares. What we're talking about there is resolution. We're going to get into more of that as we go. But just at this point, note that the squares of every piece are the same size. Now, if you look at my chest, you'll see happy little squares, indication of good UV layout. If you take a look at my arm, do you see how there's a little distortion there? I can see that. Good news is, here I've got a very strong pattern that needs to be laid out well. Here, in the arm, it's just orange. I have a little bit more flexibility with regard to the quality. Did I choose to UV the arm less well? No, not at all. I'm always trying to make the best UV layout I can. I'd like perfect squares everywhere. But in some instances, that piece of geometry just does not lay out particularly well. And that's okay. Again, in the right places. Make sense? Hell yeah on that? Okay, good. So let's take a look at some UV ideas for you guys, and then we're going to get into the steps. All right, let me get back over here to Maya. I'm going to get a new scene going, and I'm going to hide my grid just because it makes it easier to talk about what I want to talk about. Okay, now, in terms of this sphere and components, we've been talking about vertices, edges, and faces, right? Polygon components. We've talked about some other ones like normals. Those are also in there. There are also UVs. They are a component element. And when we go to UV component level, you'll notice that my sphere is covered with these sort of brownish dots that when I select turn green. These are the UVs. The difference between UVs and the vertices, because they occupy the same space. We've talked about this. Vertices are points in space that define shape. If I move the vertice, I change the shape of the object. UVs do not alter shape. UVs report shape. They tell you where you are. They're like coordinates, longitude, latitude, that kind of thing. Does that make sense? They do not alter shape and form. They only report where you are on the surface. Make sense? All right. Now, again, in terms of this object, if I want to see its UV layout, because all polygon objects have a default UV layout built right in. Where do I go if I want to see that? What's the name of that window? Internet? Do you guys know? The UV editor, that's right. Love you guys. UV editor. If I open up the editor, I should be able to see the UV shell of the object. Why don't I see it? Not selected. So I got to select the object to see its UV layout. So here we are looking at the default UV layout. This is what Maya thinks this sphere looks like if I laid it out flat. Now, we've only been talking about UVs for about 28 minutes at this point. But how do you know in your heart of hearts that cannot be that sphere if I laid it out flat? That can't be right. What makes you think that? Because the sphere is round, right? That's not, I don't see how you could take a round sphere and make a perfect square with it, right? So that tells me right away, I'm not too crazy about this. I can't be right. What else? That's a possibility. Are there more faces there or not? I don't know. That's a possibility. Anything else that would tell me? What do you guys think? Internet? You guys got any thoughts? Come on, planet Earth, talk to me. No wrong answers. Yes. Ah, this is what I was hoping you guys would see first, but it's fine that we got there eventually. What shape are the faces in the UV editor? Because that's what those squares are, faces. What shape are they? They're squares, right? Are they the same size? Over here? Those squares are all the same size, and they represent faces over here. Is this thing all squares? No, no way. I see rectangles if we go through the equator, right? Where it's nice and sunny and warm, right? So just looking at that layout, I know it can't be right because the shape doesn't make sense. I'm not too sure about how many faces are being shown. And my biggest ticket item, those are all perfect squares except for the triangles at the top and the bottom. And those are squares, and that thing has rectangles on it. In fact, the sphere is mostly rectangles. Does that make sense? So in terms of texture, if I have a square full of texture and I'm trying to fit it to a rectangle, what am I going to have to do? I'm going to have to stretch to make it fit. It's like wearing a t-shirt that's too small. It's going to distort whatever logo is on there. Does that make sense? So the problem is, this is not a good layout. I can tell by looking. It gets harder when you're dealing with a more complex object, right? When we're talking about 10,000 polygon dragons, you can't necessarily look at the UV layout and be able to tell like that. This is why we do that checker pattern thing. Does that make sense? These are the steps for applying a checker pattern to a piece of geometry in order to determine the level of accuracy for the UV layout. Does that make sense? These are the steps. Number one, we need to make a new material. So we go to Window, Rendering Editors, Hypershade, because that's where materials are, right? First, we make a new material. Rendering Editor, Hypershade. Remember, this is how we colored the zombie kill bus. All right? We go to the Create section, and we create a new Lambert. Again, we work in Lamberts in this class. I always recommend that as soon as you make a material, you name it. So I'm going to call this my checker material. Now, in terms of my checker material, if I wanted to make it red or blue or green, what attribute did I make an adjustment to previously? Gesundheit. Isn't that weird? We have something that we say when somebody sneezes, but hiccups get no love. We need to make something up for hiccups. Where do I go if I want to change the color of my material? Go to the color attribute, right? I click on this little color swatch. The color history comes up and I pick it out. But that's not what I'm doing. I want to apply a texture to the material now, a pre-created texture. So what I'm going to do is I'm going to go to the end of the color channel, and you'll see there's a little checker box at the end. These checker boxes, I'd like you to think of them as like a power strip. You can plug stuff into them. Wherever there's a checker box, you can connect something to something else with it. So what I'm going to do is go to the end of the color channel and click on this little checker box. That's step 2. This will open up the Create Render Node window. There are many nodes in here, and they all do interesting and fun things, but right now we're concentrating on number 2, checker. So I'm going to click with the left mouse button on the checker pattern. And what this will do is connect this procedural texture into the color channel of my material. And you'll see, here's my sample. Lambert, the one I made, not Lambert 1. I made one. All right. Now, in terms of this material, something I want to point out to you guys. By default, your checker pattern is going to be black and white. That's just the way it is. However, if you look at the UV editor and you look at your UVs, what color is the UV shell? Well, there's a gray background here, but what's this bit here?
Gray and white.
It's kind of like white, right? Gray and white. So in terms of your checker material, something to be aware of is that if you leave this white, you won't be able to see your shells as clearly over the white color because it'll be white on white. Does that make sense? I strongly recommend you change this color to a different one. And you can make any color you want. I'll make mine purple. Does that make sense? Because it'll be easier to see my UV shells. Just, it's a preference, but I think it's a good one. All right? So now, I have this material in the hypershade. How do I apply a material to an object? Because this is the next step. Middle mouse button and drag, one of many ways to apply the material. Okay? Now, you could also select the geometry first, right mouse button, assign to selected. Now, when I look in the UV editor, I see the checker pattern has been applied as a texture. I see perfect, happy little squares. Why don't I see it out here? I got to change my shading mode, right? I got to click 6, which is show me the texture. So here's the checker pattern applied. I see perfect squares here. I see rectangles out here. That's telling me there's distortion. And wait till you see the top. Not happy squares. Does that make sense? So this is how we determine the quality of the layout. And that's the first thing we do before we try to fix it. Does that make sense? Because sometimes the UV layout is okay. I will give you that in some instances, and it's rare. But every once in a while, the UV layout is going to be fine the way it is. Way more often than not, we need to map it. We need to fix it. We need to reorganize it. Does that make sense? There was a question. I want to make sure I got it. Any questions? We're good? Okay, I thought I saw a hand. Don't be shy. This is technical stuff. You know what I mean? Yes. Yep. Go to the color channel of the material. Go to the end of the color channel and click on the checkered box on the far right, and that will open up the Create Render Node window. And then you want to select the second node down, checker. Yes?
So Lambert is a material, right?
Lambert is a material.
And checker is
Checker is a texture. Absolutely. Again, think of it like metal. It's hard, it's shiny, it's got nice brush marks in it. That's the material. When I paint it, that's the texture. Does that make sense if that separates it in your mind? Go ahead. Did you press 6? Yes, you got to press 6. Otherwise, it doesn't show up in textured mode.
Did you refine the material?
Yep, you have to apply it. Because if you have a material, that doesn't mean that this object is made of it. And again, don't worry. We're going to do an exercise together, and we're going to go through this as a team. And then Brian and I will work with you, hands-on. Internet, you can do it with us as well. And please ask questions. I know this is weird. This is a totally bizarre process. It's not like anything else you've ever done. That makes it harder. Make sense? Okay. So now we need to talk about the next phase of this process. I've determined my UV layout is not acceptable. Therefore, it is time to UV map or reorganize my UV shells so that they work better. And what I want you to realize when it comes to UV mapping, we're not breaking the UVs, destroying the UVs, nothing like that. We're reorganizing them so that they look better to us and Maya. We're working on the mutual understanding and the accuracy at the same time. Does that make sense? Okay, so let's get into that process. All right, UV mapping. UV mapping, again, as I said, is reorganizing the UV shells. And we use tools to help us do that. And our two tools that we're going to be using, and they're the ones you will use way more often than not, I mean like 99% of the time, if not more, are the planar mapping tool and the cylindrical mapping tool. And these two tools do somewhat resemble things that we do in our world. For example, how many of you ever taken a picture? Come on, that's everybody, right? We all take pictures. The process of taking a picture is very simply capturing 3D and turning it into 2D instantly. Does that make sense? If I take a picture of my classroom, this is a 3D construct in here. As far as I know, this is reality. This is 3D. If I take a picture of it, I can create an image that I can print out in 2D. Does that make sense? I've captured this 3D idea in 2D with components of depth. All right. Also, we have another means of capturing and generating images. How many of you guys have ever had an MRI before? Okay, it always scares me how many people have had MRIs. If you've not been through this process, be grateful. But anyway, in terms of the MRI, what's going on is you're laying on your back, you know, wearing a very drafty hospital gown, and they lay you on this bed, and they stick you inside of this tube, and the tube is not much bigger than you are. It's a very tight space, and it's super awkward and uncomfortable. And when you're in there, you can literally feel your own breath bouncing back on your face while you're in there. And then they have the audacity to ask you, hey, is everything okay in there? Yeah, great. I'm dead and you've buried me. This is fabulous. Now I know what it's like. But then it gets worse, because what happens is they turn it on. You know, everybody gets out of the room. And what happens is this device, it's a huge cylinder. And what it does is it turns around your body, and it's filled with these super powerful magnets. That's why they take all the metal off of you, because it'll be like cartoonish what happens. But in terms of these big, huge magnets, they move around you. And these magnets are so strong, they're like pulling on the molecules of your being and then letting go. And the machine like measures how much the molecules move, and it generates a picture of what you look like on the inside. It is crazy loud, obnoxious. I don't recommend it. But what it does do, which is super cool, is we're basically scanning a 3D object in a cylindrical pattern, much like you would do on a scanner, flatbed scanner. But this thing is moving around you in a cylinder, and it generates flat 2D images of this 3D object. Does that make sense? This is very much like the cylindrical mapping tool, ideal for mapping cylindrical shaped objects or things that are cylinder-like in their design. So the two tools, when you see them, this is the planar mapping tool. This is the one that works like a camera. All you have to do is tell it what axis to take the picture on. If I want to take a picture of somebody's face, I'm not going to take that picture on the x-axis, because that's the side view of my head. If I want to see what your face looks like, I'm going to take that picture in Z, depth. Does that make sense? Because that's what I want to see. So it's all about where am I taking the picture from. The cylindrical mapping tool, again, scanning in a cylindrical pattern. The key to that tool is making sure that the object is in the same axis as the tool. If I'm scanning in a pattern like this, like an MRI machine, I can't stand up. Does that make sense? I have to lie down to be inside the cylinder to be scanned properly. Make sense? Okay. Now, in terms of the tools, they have these fun little manipulators that allow you to change the size of the picture or the size of the scan. And they also have this cute little red T in the corner that you can click on that will allow you to change a little bit the angle that you're taking the picture on, or the angle that you are doing the cylindrical scan on, because some objects are laying down and some are standing up. Does that make sense? Okay, so those are your manipulators, the UV mapping tools. All right. Are you guys ready? Okay. Let's get out our activity, and here's where we're going to put it to the test, what we have figured out and what we do not know yet. So this is our opportunity to work together. So I'm going to set my project to my activity file folder. And I'm going to open my UV mapping activity. And you will see I've got 3 objects in here, a plane, a cube, and a cylinder. And we are going to check the UV layout first, see if it's good or bad. If it needs to be adjusted, we're going to fix it. Make sense? Okay. So the first thing we have to do is what? And the internet is also included in that question. What's the first thing we have to do? First I'm going to go to the UV editor and see what I'm working with. But you're right. Next, I'm going to have to do the material thing. So first things first, let's take a look at the UV editor. Where's the UV editor? It's under UV. So if I open up the editor, here it is. Again, all kinds of fun stuff going on in there. Okay. I don't see any of these objects in here. ¿Qué pasó? Got to select them. So I'm going to select the first piece of geometry. This is the geometry plane. This is what Maya thinks it looks like in the UV editor. What do you think? Brian's good with it like it is. Close enough. Ballpark. Not even close. But I have to be honest with you. To be fair to Maya, I made the UV layout even worse than it was. So you're typically not going to be this bad off. Not with this lighter piece of geometry. But I made it worse. Now, we've determined it's no-go. So the next thing we have to do is verify 100% what's bad, and this will also enable us to fix it and create a better layout. So the next thing I need to do is what? I need to add that checker material, right?
Yeah, create a Lambert.
Create a Lambert. Awesome. So here we go. We're going to do the material thing. There are some things built in that will do some of these similar things. I like to show this process just because it's very similar to the creation of materials and stuff that we've been doing up to this point. And when it comes to applying the texture to the geometry, it's much more like this. Does that make sense? Is there a time saver? Yes. Does it reinforce some important things? It doesn't. Does that make sense? So is there? Yeah, absolutely. So first things first, we're going to make that new material. Window. Again, make sure you're following along with me if you need to, and also writing down anything you're missing. Because what's going to happen is when you guys are UV mapping on your own, unfortunately, I'm not available. So this is your chance. Yes?
Is there a way to save the checkerboard material
No, there isn't. But the good news is once you create a checker in your scene, you can put it on every object if you want to and use it for the entirety of the scene. But what you will come to find out later, what he was getting at is there is the ability to automatically generate a checker pattern for things, but it doesn't help you with texture application. And that's why I like it. It reinforces those ideas, things that we've already covered and things we're going to get into again.
And for example, I'm going to create, and I'm going to select everything and apply one material on it. Will it be the same or is it on the different direction?
That's a good question. It's going to depend on the UV layout and the orientation of your shells.
First, you have to create a shell and then apply one material for it, right?
Yes, but you will apply that checker to each piece.
Oh, I cannot just.
You could. If I wanted to, I could select everything, but again, I want to show a pattern so that we can learn the pattern. Because this is repetition is king when it comes to learning, and that's why I try to go back to things that we have done before, because that will help ingrain it in your memory. Does that make sense? So. Oh, where is the hypershade?
Windows, rendering editor, hypershade.
Oh, thank you. I do so appreciate that, because on occasion, I get distracted by good questions. All right, so here I am in the hypershade, and I want to do what? Make a new material. So I go to my Lamberts, and again, we work with the Lamberts just because they're safer, a lot lower rendering times, a lot less, or fewer issues. So I've got my new Lambert, and something I want to throw out there in terms of the Lamberts, I know I've talked about this before. You'll notice that there's a material viewer in the hypershade, and there are attributes in here, but I have noticed in Maya 2016 and 2017, when you start playing with the attributes in here, it has a tendency to crash the application. So as soon as I make the material, I get right out of the hypershade, and I adjust the attributes in the main interface, because I've had a much higher level of success when dealing with it in there. So in my attribute editor, I'm going to name this new material checker material. And again, I can use this for all of my objects in this scene once I've made it. So it's worthwhile. All right, so what's the next step? I have my new material. I got to apply that texture. What are the steps for applying the textured material to the material I've just created? First we have to add the checker material, the texture, to the material. First we color it, then we apply. But you're right, we're going to do both of those things. So I go to the color channel. I go all the way to the checker box at the far right. Again, thank goodness this is repetitive. Click on the checker box. It opens up the Create Render Node window. And again, we want checker material, which is the second node down. So I choose it. Again, I like to change one of the colors. You can make it any color you want, but I do recommend you color it. So now that the material has been adjusted, I don't have to mess with it anymore. Hooray. So now I'm going to apply it. And again, middle mouse button drag, and it will show up. If you don't see the material, what do you most likely have to press? 6 to give you textured mode. Again, 5 is not going to show the texture, but 6 does. Now, when I select the geometry, I see happy squares in the color channel, or in the 0 to 1 space here. Do I see happy squares over there? No. So this is, again, is an indication of bad UV layout. I knew that just looking at it, but this confirms it and gives me the ability to fix it. I'm sorry? No, it's not masking it. And I see what you're saying in terms of why don't I see it out here. It's not masking it, but what's happening is it's showing you that this is where color information goes, because these other quadrants can contain other information, like normal maps, spec maps. You can put transparency maps. There's all kinds of different maps. But this is where Maya goes by default for color information. Does that make sense? So that's why it shows up there. So yeah, it's not masking it. That's an interesting thought, but that's not what that is showing you. And I think that'll become more obvious to you next lecture when we apply textures to everything. That is a good question. Yeah.
When I created my texture, I clicked off. There's some reason selected my object and I lost in my attribute editor and lost the texture. Where does it go? Where's like my palette, I guess?
If you go back to your Hypershade, that's where your materials are, and you should be able to access it there. And then you can just click the color attribute again, the checker box at the end, and just recreate that texture pattern if you've not done so already. All right, so now I have the checker on there. I can see it's not a checker. So now we go to the fixing part. So what you need to do when you're UV mapping, because that's what happens next, is take a look at the object and try to determine what kind of object am I looking at? What are the shapes I see predominantly? So for example, if I'm mapping this speaker, you see that? If I'm mapping this speaker, it's got a lot of flat faces on it. So I would probably use which tool, do you think? The planar mapping, right? Because that's kind of a flat faces type surface, right? But let's say I'm mapping a marker. What am I going to use with that most likely? Cylindrical, does that make sense? So what tool do I need as your first stop? I'm going to try planar. Does that mean I can't planar map a cylindrical object? Of course I can, if I want to. There's no rule that says you have to do it. Probably one of the more important things for you to understand about UV mapping is it's not A, B, C, it's done. It's a riddle. It's a puzzle. How do I lay this thing out? What tool do I use? What can I do to get a good layout? It is a process. Does that make sense? It's not a, you've ever heard that saying, and life is not the destination, it's the journey? This is heavy in journey. Does that make sense? We've got to figure this out. So this object, if I'm going to map it, which tool do you guys think I'm using? Any thoughts, my internet Earth friends? Come on, planet Earth, where are you guys? Planar mapping tool, absolutely. So the way you use the planar mapping tool, these are the steps for using the planar mapping tool. First, select the face or faces you wish to map, because you don't necessarily want to map them all at once. Sometimes you just want to do a couple at a time. This object happens to be just one face, but I might map some of them and not others at this juncture in time. So first, I select the face or faces that I'd like to map. Next, I have to determine what the optimal axis is for taking the picture, because that's what the planar mapping tool does. It takes pictures. So I'm going to activate my move tool because it makes it very easy to see axes. Which axis do you think would give me the best picture of this object? What do you guys think? Let's have a vote. How many of you think Y? All right. How many of you think X? All right. How many of you guys think Z? All right. Internet, what's your vote?
Carl says Y.
Carl says Y.
Scott says Y. Scott says X.
Let's check it out. Let's try. So here's the way the planar mapping tool works. Z. There's always a vote for each one of them. It's very seldom there's everybody on board with one, and that's fine. So I'm going to go to UV, and you'll see the planar mapping tool. Again, big ticket item here. You have to go to the options box to tell it which axis to take the picture on. Now, here's where you tell Maya which axis. I'm going to leave it on X axis for right now, and I'm going to run the tool by clicking Apply. Do I see happy squares on there? If you look at my example, are you guys getting happy squares? No. So you know what that's telling me? Not that axis. Does that make sense? So I'm going to hit Z for undo. Let's try Z. Did that give me happy squares? No, not the right axis. Let's choose Y. Do I see happy squares? Yeah, that's what we're talking about. Now they have been laid out better. Okay? And again, in terms of that layout, I can adjust these little cubes here on the sides to try to give me some nice happy little squares. And again, if I click on that cute little red T, you'll see it over here, click, it activates what kind of looks like the extrude tool. And if I click on this circle, I can actually change the angle that I'm taking that picture on as well. All right? But luckily, it's straight on, gives me a nice happy X. Yes? You have to click this little tiny red T in the corner. That allows you to manipulate. You got to then click the blue circle that appears, and then that'll give you some rotate capacity. All right? Now, let's go back to the UV editor, and you'll see what I have created is a nice, happy little square. This looks very much like that. That's why I'm seeing this pattern well represented there. Does that make sense? That's my goal. What you will notice when I'm UV mapping, as I create shells, I drag them out of the 0 to 1. And the reason I do that is because objects typically have more than one face on them. So as I create shells, I drag them out of the 0 to 1. Once the 0 to 1 is empty, I know I've mapped the entire object. Does that make sense? I don't have to wonder, oh, is there a part I didn't do yet? We're going to do some more UV mapping, so if that doesn't make sense yet, it will. Now, something I want to throw out there, you'll notice I still have a pattern on here, even though I'm not in the 0 to 1. That's because whatever texture is in here repeats infinitely out here. Now, another big ticket item for you guys. Note the size of the squares. If I want to move this UV shell, or make it bigger or smaller, which is something we do, if I make it bigger, the squares get smaller. If I make it smaller, the squares get bigger. I've made the squares bigger or smaller, but have I distorted them any? No, I've still got happy little squares. They're just different sizes. The size of the shell, that's where we're getting into resolution. Okay? I'm not changing the squares to make them poor quality. I'm just making more of them or fewer of them. The proportional relationship between the shell and the surface is still intact. Does that make sense? There's no distortion taking place. Yes? This is my UV shell, and the way I moved it is I selected all the UVs, and then using my move tool, I moved it. And you have to be in UV mode to move the UVs. Now, something important to realize, which was the thing I was going to touch on next, it is possible to grab a single UV. And if you try to then move it, what you will notice is that distorts your texture, because I have changed the proportional relationship between the shell and the surface it represents. Does that make sense? I don't want to move a single UV, or it starts to distort what I've done. If I move everybody, there's no distortion. Does that make sense? It's intact. That's my UV shell. That's okay. Nope, that's totally fine. Ultimately, when we're all done UVing an object, we're going to take that shell and bring it back to the 0 to 1, and it is of the utmost importance it fits inside. All right? Even hanging off by 1 pixel out of the 0 to 1 does not count. I need that thing to be completely 100% inside the 0 to 1. Does that make sense? Does that make sense, everybody? Okay, and again, you'll notice that the squares change size. That's okay. I have accurately laid it out, so no matter how big the shell is, everything's good. All set? Did a hell yeah on that? Hell yeah from the internet? Okay. Thank you. I hope that was Carl. All right. So here we go. We got good layout on this plane. So now we're going to do the cube. Okay? What do you think is going to be the first thing that I need to consider before I even delve into this? You guys have any thoughts?
Getting the checker pattern Lambert onto the object.
I'm going to have to apply my checker pattern to find out how good the layout is. Is this object have one face?
Got the select faces.
Select the faces happens next. Scott's on board. So you know this doesn't have one face on it, right? It's got multiple faces. So when I take these pictures, is it all going to be from the same angle? No. I'm going to have to take pictures from different angles. Does that make sense? So here we go. Step 1, apply my checker pattern. Window, rendering editors, hypershade. I still have my lovely checker pattern, so I can just put it on this thing. How's my layout? Happy squares? Niet. So time to fix it. So let's start with what we know. I grab this face on top. What tool am I using to map this object, you think? Planar mapping for sure, right? It's a series of planes, no brainer. So I've got this face, time to map it. My next question is what? What axis am I taking the picture on? So if I want to get a picture of the top of this cube, what axis are we talking about? Y. Y, absolutely. Good for you guys. Again, UV, planar mapping, we choose the Y axis, and we're still set for that, so hooray. I take the picture. I have created a UV shell, and I drag it out of my 0 to 1. Now, in terms of my UV shells, what I typically do is I try to organize my shells when I drag them out of the 0 to 1, sort of in keeping with where that shell is on the object, just to help me know what is what. So since this is the top of my cube, I'm going to leave this sort of in the upper part of my desk space here so that I know that that's probably the top of the object I'm talking about. All right, time to take another picture. If I want to take a picture of that face, what axis is that face? Z, right? And again, that idea of dragging your shells out because that lets you know when you're done because there's nothing left. You see how there's more stuff in here? I know I have more mapping to do. So Z is the axis I want, so I choose Z and take a picture. I get another shell. All right, and you can see my cube is already looking better. What axis do I take that picture in? What do you guys think? You think X? Anybody disagree? Anybody agree? Planet Earth, what do you think? X?
They agree?
X is correct. I choose the X axis because I'm looking right at that one, so that must be X. I create another shell, drag it over here, and you can see there's still some stuff in there, so I know I have to map. Also, my object looks really bad, so I know I have to map. Here's where it starts getting interesting. What axis do I map that face on? What do you guys think? Gesundheit.
I'm getting wide from the
Some Y, yeah. Well, it's hard to figure out here, right? Because I'm trying to get this face. I know that that's the x-axis, but it's kind of on the inside. So it looks, things are not the same as they were with the other faces we did. Ah, Peter is very smart. You would think negative x, right? Because this is the negative side of the x-axis. That is a logical deduction. However, when I go to the planar mapping tool, is that an option? No, it is not. So what we're going to do instead is choose X as it lays, take that picture, drag that shell over there. But good for you, Peter. Similar issue here. What axis do I take that picture on? What do you guys think? Planet Earth? Z across the board from internet. That's correct. I choose Z. Let me come over here and go into textured mode so you can see it happen, because that's the cool part. Get a nice picture there. I've still got some shell in here. Oh yeah, that guy on the bottom. And again, you could select the shell in here if you wanted, or out there. Like all windows in Maya, they work together. What axis am I taking that picture in? Y is correct. So I choose Y, take the picture, that's the bottom of my cube, down there. All right, so in terms of my object, it's looking pretty good. I'm seeing happy squares everywhere. And that means that I have laid this thing out well. And when I look at my squares, have you noticed that each face, the squares are the same size? Then that means that each of these shells is the same size relative proportionally to the object. So now when it comes to getting these done, finishing up my UV layout as far as what we're going to be covering today, what do I need to do next? What does the internet say, Brian? I got to move them 0 to 1 space. Good for you guys. Now, in terms of the 0 to 1 space, no mystery. What shape is this? It's a square, right? So what I'm going to do, and you saw me already get started, I'm going to kind of like grab these things and just sort of make a square-like pattern, because I know that's what they're going to do, right? All right, and I'm going to grab everybody at once. Again, I could grab my shells one at a time and try to size them, but what that's going to do here, I'll do the top one. What that's going to do if I do that is change the resolution of these shells relative to each other. And I don't want to mess that up. I want them to have the same size. So I will grab everybody at once and get them down into that 0 to 1 by scaling them all the same. And I'm very careful to make sure that everybody fits completely into the 0 to 1. Now, a couple of things you'll notice. I'm not putting shells on top of each other. UV shells can be laid out in 2 different methods. I can have collage UVs, which is what we have and what we're doing for this class, where all of my shells occupy separate space. But it is possible to have stacked UVs, where the shells are on top of each other. We're going to learn more about why we choose one over the other next class. But for this class, and for right now, everything gets its own space in the 0 to 1. Nothing is overlapping. Nothing hangs off. Everything fits in there. Make sense? Collage UVs. Okay. So now we've done that guy. Yeah, go ahead. Yeah. Yep. Yep. Yep, totally fine. I could have run 3 of them this way and then 3 of them that way. It doesn't make any difference. You want to fit them in there. But you do want to make them as big as you can. You want them to fit in that space and use up as much as possible. Think of the 0 to 1 like money. You don't want to waste any money. The bigger these shells are, the more money you keep. Does that make sense? This is just giving it away. So you could fit all of your shells in the 0 to 1. Hey, no problem. There they all are. But look at all the money I'm wasting. Does that make sense? So you want those shells to occupy that space.
So since you shrunk down all the places to have the nuclear array, you expect the size of these squares in the texture material? Like, could you have made the texture checker squares smaller?
Oh yeah, absolutely. Absolutely. You can totally alter how big those squares are, because if you really wanted these things to have the same size squares, which is not something we have to do for this class, but in terms of could you let there be more squares here, smaller squares? Absolutely. But what I want to talk about today that is important is resolution, and that's why I'm allowing those to be different sizes. Now, important follow-up to that question. If this was one object, let's say that this was the lid to a box, would I want these things to have the same size squares? Definitely. In this class, I want those the same size. Again, there are instances where that's not what you want. But for this class, I would want those to be the same size squares. Does that make sense? And that's why I touched on that. Yes?
I understand what you mean.
Why? Because this is where Maya goes specifically to find color information for texture. When I selected my Lego man, was there paint anywhere out here? No, it was all in here. Because if I want to paint something a specific color, if one side of this cube is blue and one's red and one's orange and one has a picture of my foot on it, I'm going to have to get it into here to get those textures exactly where I want them to go. Does that make sense? Enough for today? Okay. It'll make more sense tomorrow, I promise. There's just not enough hours in my day. I think it'll be more clear for you tomorrow once we do that. But today I'd like you to concentrate on the ideas of UV layout quality and resolution. Those are really my big things today. But I'm glad you're asking about that because that is important. But I think that'll make more sense. Well, not tomorrow. I say tomorrow, but what I mean is Friday.
Some question.
There's no such thing. Go ahead.
In my ridiculous typing,
No.
I lost how to get what you were considering a snapshot. It was a
Planar mapping tool. Yep, under UV.
UV, I have planar.
Yep, that's it. Oh, they shaved off mapping tool. It used to be called planar mapping tool. They changed the name of it. Now it's just planar, yeah. Because that's more clear. I'm going to get some emails from Autodesk. What are you telling these people? I liked it better when it said planar mapping tool. I don't know. Even planar mapping, I think, would be better. Planar itself, I don't know. I guess I've worked with wood before, so that's. Oh, go ahead, Brian. Yes, please. Internet, go.
They're wondering, is 0 to 1 just for color? What is all of the other grid for?
That's a great question. The other grid elements are for different kinds of maps. This is where Maya goes by default to find color information only. There are other types of maps like normal maps and spec maps and transparency maps, and there are even maps that determine brightness or darkness of a relative object. And those maps will occupy other areas. But this is where Maya goes to find color information specifically. Good question, though. Yeah? Here's where you need to understand that the grid is big or small based on what I want it to be. 0 to 1 is as big as I say it is. It looks small because if you look at it relative to all this surface out here, you'd be like, whoa, look, I'm wasting all of this. Why would I do that? But in terms of the 0 to 1, which again it's a bit misleading when you look at it, you would think it's so small. This is as big as I say it is. This thing could be 1 inch by 1 inch. This could be 10,000 miles by 10,000 miles. Does that make sense? It's like the grid in Maya, arbitrary. It's what I say it is. Yeah. I could UV map the entire planet Earth and make it fit right there. Does that make sense? But I would see how you would think that, because you're like, wow, this is so big out here. It's all relative, says Albert.
Why is it that in your 0 to 1 space it's gray and you can see the character, but texture is like your square
Oh,
is green and black?
because I'm in component mode. If I select this in object mode, oh, hey, how come my texture's not appearing there? Look at that. That's funny. Typically, what you'll see in there is the grid, the checker pattern. For reasons I have no idea, Maya's not showing me that. Not really sure. Oh, there we go. I had to press 6 on my keyboard to get it back again. I guess maybe I hit 5 or something. I don't know. But yes, you will see the texture in there. Does that make sense? All good? Scale tool. You literally select the UVs and scale them, bigger, smaller, or move them around. All right, let's get to this last bad boy. Time to work the cylinder. Again, at this point, you should get the rhythm. So what's the first thing I do? I apply that texture. So I go to the UV editor and I look at it and I see this is what Maya thinks that cylinder looks like laid out flat. Does that look good to you guys? No, it is abysmally bad, obviously. That doesn't even look close to a cylinder. But we do apply the checker pattern so that we can see how good of a job we're doing at fixing it. So I go to Windows, Rendering Editors, Hypershade. Here I am back in the Hypershade. We know it, we love it. So we apply it to the cylinder. And we are, in fact, confirming the point that, yes, this is poorly laid out. Now, this is a little bit trickier. This surface is round, but it's also flat. Which tool do you think I use? How many of you guys think I'm using the cylindrical mapping tool? All right. How many of you think I'm using the planar mapping tool? All right. What does the internet say, Brian?
Getting both.
Yeah. It's hard to say because, again, if you look at this surface, it is round. But in terms of its most prominent characteristic, it is flat, which means those of you who chose planar are correct and can mock everyone who chose cylinder. No, no mocking in here. All right, so here we go. I go to face mode, and I select all of the faces on the end of this object. Everybody. If I'm planar mapping this, what axis am I taking the picture on? X is correct. This is the axis I want to get this image on. So I go to my planar mapping tool, because again, this is just a big plane. It is round. Choose X and hit apply. And you see I've got happy squares on the end. So I know I've chosen the correct axis. When I open up my UV editor, I see that I have created a round flat surface. So I drag it out of my 0 to 1. And then it's time for me to map the next piece, this side. Now I use the planar mapping tool on one side, so you know I'm going to use it on the other side. I grab all of those faces. What axis am I mapping them on? X is correct. UV, planar mapping, make sure I'm set for X, hit apply, and again, yay, I've got happy squares. I drag this new shell out, and then I can see I've still got some faces to go. Well, yeah, it's all these guys in the middle. Now, if I grab these guys, how do I map them? What's my tool? Cylindrical mapping tool. Could I planar it? Absolutely. Might that give me a better result? Maybe. But cylindrical object, very, very likely cylindrical mapping tool is going to work for me. So this time, I go to UV and I choose the cylindrical mapping tool. All right, and I'm going to make it a little bit bigger so you can see what it's doing. Do I see happy squares there? No, I see crazy zigzaggy, like Charlie Brown looking stuff there, right? If I look in my UV editor, I see these sort of like apple core looking shapes. What's wrong? What did I do wrong? My cylinder is lying down. You guys see that? Which direction am I scanning? You see how the tool is scanning in this direction? It's sort of a half cylinder here. Does that make sense? My object is lying down, but I'm scanning it this way. How do I change the axis that my cylinder is scanning on? Who can remember? Internet, I'm looking at you. It's the little red T, that's correct. So what I'm going to do is come down here and click on that little red T, which activates that circle. Click on that, and then now on the Z-axis, I can rotate that thing, and I can literally plug in a value there of 90 degrees, which will allow it to line up much more accurately. And do I see happy little squares in there now? Do you guys see happy squares? Now there's a little distortion there. I'm going to adjust using those little manipulators. What's that? When I create a new shell, I'm just reorganizing the shell that was previously set up. So I'm not deleting anything, I'm just reorganizing it. So now I go to my 0 to 1, and you can see I am looking at happy squares here and happy squares here, but are they the same size? Do these squares look the same size to you guys? What do you think, Internet? Planet Earth, my digital friends? I'll say my digital friends.
They don't look the same size.
They do not look the same size, and that is because the resolution of these shells relative to each other are incorrect. Now, just to further drive that home, if this is a cylinder, right? This is my shell for my cylinder. If I took this rectangular piece and I wrapped it around this round piece here and then put this other round piece on top, do you think that the cylinder that it represented would look like this cylinder? What do you think? If I took this rectangle and wrapped it around this object, you have to kind of think a little bit in 3D. Would it look like that thing, do you think? Probably not. If you look at how big these are, and to be honest with you, I'm not even 100% sure that this rectangle, if I cut it out, if it was on paper, if I cut it out and wrapped it around this perimeter, I don't know if it would make it all the way around. But if it did, it would not be a very tall cylinder. So instead of like a soup can, I think we'd be looking at more like a tuna fish can, something a lot shorter. Does that make sense? I don't see that. And what that's confirming for me is the fact that the resolution is different between these two objects. So in terms of fixing that, I can either make these things bigger or smaller, or make this thing bigger or smaller. Which one do you guys want to do, the rectangle or the circles?
Every time I try to like rotate the pattern, triangle will
Make sure you're in UV mode. Yep, because if you're in like object mode or what have you, you're going to move the object. Yeah. Make sure you rotate the tool so it's scanning on the correct axis, because that's what typically gives you the wrong layout of the squares. You got to rotate that cylinder. So here's what I'm going to do. I want to make these squares the same size. So either these need to get bigger or smaller, or this needs to get bigger or smaller. So what I'm going to do is I'm actually going to leave the squares on this side, or the squares of the main part of this thing alone, and I'm going to make an adjustment to these circles. Now, in terms of my circles, I really have two choices. I can scale them both together if I want to, because do you think these circles are the same size on this object? Do you think they're the same on both ends? They should be the same size. So I can either change their size together, or I can change the size of one of them and then make the other one match. Both will do the same thing. Does that make sense? Either or. So I'm going to make, I'll do this one because it's easier to see. I'll do this one first. I'm going to grab all the UVs for this side of my object. And what I'm going to try to do is make this square here match the size of that square there. I'm going to go to my Move tool. And I'm looking over here. I'm not even looking over here. I'm looking over here. And I'm trying to get those near each other. And incidentally, this is a texture seam. Remember we were talking about the cuts in the ocean and the seams? You can see how that creates a seam. And what I'm going to do is, again, I want to make this square the same size as that one. So I'm going to be scaling it. If I make it bigger, the squares get smaller, so that's the wrong way. I'm going to make it bigger so that the squares get bigger. Then I'm going to move it. And it looks like it's a little bit too big, so I'm going to scale it in just a smidge. There we go. That's still a tiny bit big. Take it down just a little bit. All right. So now the squares on the end are the same size as the squares in the middle. Does that make sense? So if this is the right size, then I can take this guy and scale it and just make it match. And if they're the same size, I know I've got the same resolution for both of those. Does that make sense? And then, of course, our last step is what? What do you say, my digital friends? What's the next step? Get it into the 0 to 1. That's right. So I'm going to grab my shell, get it down to the 0 to 1. It's obviously too big. I'm going to have to shrinkify it. Again, I want to use as much of that space as I can. Fit that bad boy in there. All right. So now these guys have been UV mapped, and their shells are the correct size relative to each other. Now, before Brian and I walk around to see how you're doing, I want to show you one idea of resolution first, because the whole, why do I make the squares the same size? You know, that seems like voodoo. So I want to talk about that for just a second. Let's look at this image. This is a picture of an oil barrel. This oil barrel is a low resolution image. What that means is there's not many pixels that make this picture, right? The pixel is the smallest unit of an image, just like atoms are the smallest unit in our universe. And we could split them, but that's, you know. But the idea is that's the smallest thing. Pixels are the smallest thing. And what that means is I can't go any smaller than a pixel. So if I've got a low resolution image, the closer I get to it, it starts looking jaggy. And I can see each little pixel. Does that make sense? Now, here's another image of an oil barrel. This is a high resolution image. And what that means is if I zoom in, even at several times, I still see a lot of detail. But if I get close enough, eventually I can see the pixels. But I had to go way in there to see the pixels. Does that make sense? This is a high resolution image. So in terms of my imagery, the more pixels I can fit into my picture, the higher the resolution of the image. Does that make sense? Okay. So when we're talking about the 0 to 1 space here, I'm looking at an object that's in here. Guess what the smallest unit inside this space is? It's the pixel. Does that make sense? So the bigger my shells are, the more pixels I can fit inside. The more pixels that fit inside this shell, the higher the quality, the resolution of the image. What's that? Which I set. Absolutely. But no matter what resolution I create the entire 0 to 1 to have, I can only fit so many within the shell. Does that make sense? Because it's surface area. I can make this space 1024 by 1024. I'm not getting 1024 in there. That's not as big as the entire space. Does that make sense? So as a result, the bigger these shells are, the more pixels I get inside. The more pixels I get inside, the higher the resolution of the image. Quality. Make sense? Okay. All right. Just want to make sure we got that out there. Brian and I are going to walk around and see how you guys are doing with this particular. Oh, question from my digital friends. Go ahead.
Peter asked, how many pixels can you fit into one unit between 0 and 1?
That's an excellent question. As many as you want. Infinite space, and I will show you that when we get together tomorrow. Or I'm sorry, Friday. For me, it's always the next day. Yeah. On Friday, when we get together, we're going to talk about those elements specifically. But for today, we're just talking about UV mapping. So Brian and I are going to walk around and see how you're doing and start answering some of the questions you're having, because I know you're having technical difficulties, and we will help you delve into them. For those of you who are my digital friends, make sure you come see Brian after class, because he will be in the Hangout waiting to answer questions. He loves to answer questions. But first, I wanted to show you guys your skill check, and that is we are going to UV map the jar you built. You built a jar for one of your skill checks. Now we're going to UV map it. So what I want to see when we get together on Friday, for those of you who are in my local class, I want to see you UV map the jar. Good layout. Nice shells, best use of the 0 to 1 space. Does that make sense? Okay, so that's what your skill check is. For my online friends, my digital buddies, again, all of this stuff is due on Saturday in terms of its submission to FSO. Please don't wait till Saturday to start working on this stuff. And of course, my local class will also be submitting to FSO the skill checks, but I visually check them off with them in class. Since I'm showing you how to UV map, do you guys think that this is going to be part of one of your turn-ins coming up? Yeah, you know it is. There's going to be a turn-in where you're going to be UV mapping the objects that you've built. And what you will start to understand very quickly is that the quality of the model that you build absolutely affects the ease and the quality of the UV layout that you can generate. Does that make sense? So this is where we start to see where bad modeling habits can lead to more frustration on your part. Does that make sense? Because this stuff is all interdependent. It's all part of that creative pipeline that makes movies and games. And this is just one of the stops. Make sense? Hell yeah? All right, so your skill check is UV map the jar. And so now Brian and I will walk around and see what we can do to help you guys out with your UV mapping questions. And we don't have to record anymore because my digital friends, exactly, my digital friends know everything they need to know. So I will see you guys on Friday. And we will get into more of this UV mapping and texturing because it's important. So we will definitely be delving into that.